Dr. Shivaswamy meeting. Yeah. Yeah, Zoom meeting or YouTube, both are there. Okay.
So officially it has started.
Okay, great. So it's already 10:30. We start.
Your email ID, if you could WhatsApp.
Good morning, Dr. Patnaik.
Good morning, sir. Good morning very much. Good morning, sir. Namaskar, sir. Ravichandran, sir. And all of them. Thank you, sir.
Namaskar.
Good morning to everybody. Yeah.
Good morning, Dr. Alvin from Myanmar. And welcome, Dr. Sanjay Srivastava.
Yeah.
Would like to see you. Please switch on your video in the beginning at least, and later on during the photo session, of course.
Okay. Thank you. Good morning. Namaskar to all of you colleagues. Namaskar from Bangkok. Yeah. Thank you.
So, Tyagi Sahib, shall we start now?
Yeah, please.
So yes, Professor Raju.
Good to see you, Sanjay, Dr. Sanjay.
Thank you. Good to see you.
Yeah.
Your mic is mute, Dr. Tyagi. Professor Raju, your mic is mute.
A very good morning to you all. Namaskar. On behalf of South Asian Meteorological Association, I warmly welcome our distinguished chief guest, Dr. M. Ravichandran, Secretary, MOS, Government of India, eminent speakers of today's session, and participants. The World Meteorological Day theme of this year is celebrated by South Asian Meteorological Association is early warning and early action, hydrometeorological and climate information for disaster risk reduction. It is well known that impact-based early warnings to the public are vital to save lives and livelihoods. Being prepared and able to act at the right time in the right place can save many lives and protect the livelihoods of communities around the world. Today, we have more deliberations with eminent personalities of this today's event. So at the beginning, I request Chairman, South Asian Meteorological Association, Air Vice Marshal Professor Ajit Tyagi to give a welcome address.
Thank you, Professor Raju. Dr. Ravichandran, Secretary, Ministry of Earth Sciences. Esteemed distinguished speakers, Dr. Sanjay Srivastava from SK panel, the head of the DRR. Dr. Mahapatra, DG India Med Department. Professor Kamal, Pro Vice Chancellor of Dhaka University. And Dr. Prema Gapso and Dr. Mandira Shrestha from EC Mode. Thank you, sparing your valuable time, and heartiest welcome on behalf of South Asian Meteorological Association and our joint organizer, Indian Meteorological Society. I also welcome members of the Advisory Council of the SAMA, members of SAMA and Indian Met Society, and other participants. Today we are celebrating WMO Day by hosting this webinar jointly with the India Met Society on a very important theme as brought out by Professor Raju. South Asia is prone to all types of hazards and disasters, ranging from cyclones to the cloudbursts, the avalanche to landslides, thunderstorms and dust storms, lightning, flash floods. So you name a hazard and it is there, and we have a complex topography. In the north, we have a massive Himalayan ranges extending from Afghanistan across Pakistan, India, Nepal, Bhutan, and also affecting Myanmar and Bangladesh. In the south, we have vast Indian Ocean, Arabian Sea, and Bay of Bengal. Tropical climate with cyclones in both pre-monsoon and post-monsoon affecting the vast coastal lines. And as of now, you see, we had a statement from the UN Secretary General on 24th, the day following the WMO Day, He highlighted that even today, despite of improvements in weather warnings, 1/3 of the population in developing and least developed countries don't have access to the weather and climate information for disaster risk reduction. And situation is so grim in Africa that 60% of the population is out of this network. He has launched a very ambitious program of 5 years under the leadership of WMO to reach last person in the remote area of the globe. Now, of course, the National Met and Hydrological Services are doing an excellent job and they will continue to do job, but this cannot be done alone by the National Meteorological and Hydrological Services. And here, professional societies like SAMA and IMS and other NGOs, science NGOs can play a very important role. So this in AIM, SAMA is committed along with its partners and the South Asian countries to take early warning systems through public awareness, outreach, and citizen science to the large population of these areas which have so far not have access to these information. So with this in aim, we are starting today's webinar, but we'll follow it up with the concrete plans of our MET education to the school children, general public awareness to the users about the early warning and early action. Once again, early warning systems through public awareness, outreach, and citizen science to the large population of these areas. There seems to be some problem in my audio.
सर आप YouTube बंद कर
Aim,
YouTube?
we are starting to
You are streaming YouTube.
Oh, okay. Let me mute it.
Anyway, so I'm thankful to Dr. General Public Awareness for agreeing to deliver a keynote address. He is one person who has a complete mastery of the Earth system. He worked as a scientist at Indian Institute of Tropical Meteorology, a senior scientist at INCOIS, and before joining as secretary, he was the director of the National Center for Polar and Oceanic Research. So there wouldn't have been a better expert and person to deliver, and he is responsible taking early warnings both related to the atmospheric, ocean, and the polar regions. So I extend heartiest welcome to him and thank him for delivering the keynote address. Thank you. Jai Hind.
Thank you, sir. Thank you very much for giving this welcome address. Since this event is jointly organized by India Meteorological Society, so I request Dr. D.R. Patnaik, Secretary, India Meteorological Society, to deliver the address.
Namaskar, respected Secretary Sir Ravichandran sir, respected DGM sir, Dr. Mahapatra sir, all our distinguished members from the South Asian Meteorological Society and neighboring country. So it is very unique opportunity for all of us to sit together and discuss about the theme of the this year World Meteorological Day. That is a very important thing, particularly for this our country and neighboring countries. All South Asian countries are widely affected by the natural disaster. So early warning and early action is a timely step where we can minimize the risk associated with the disaster. And as you know, Indian Meteorological Society working with all our agency to popularize the science of meteorology and also the enhancement of its knowledge, capacity building. So IMS is already involved in this thing with all the Met, just like IMD, it is closely working with the National Met Service, IMD, and also the other meteorological society that like SAMA and this thing. So that this objective, whole objective is to how the capacity building over this region is improved through training and also the transport technology that is going on. So we are working with South Asian countries like SASCOP, then SWP. There are several projects are already there on the WMO platform, like severe weather forecasting demonstration project. So IMS, whenever IMS is getting opportunity, we are working with this organization as well as the society. So I wish a very successful deliberation on this day, on this occasion, and on a very important thing. With that thing, I just conclude my remark. Thank you very much, sir. Namaskar.
Thank you, Patnaikji, for giving this brief information about IMS activities and IMD's role over the South Asian regions. Thank you so much. Now, going for the next agenda, the message of World Meteorological Day by the Secretary General of WMO, Dr. Petteri Talas. I request Dr. Swagata to play the video.
Greetings from the World Meteorological Organization Secretariat in Geneva. Happy World Meteorological Day. The top priority of WMO is to protect lives and livelihoods from weather, climate and water extremes every minute of the day. That is why the theme of this World Meteorological Day is early warning and early action. It celebrates the success of meteorological and hydrological services in improved early warning systems. It also shows all the achievements in disaster risk reduction. But we face many challenges to make sure that early warnings reach those who need them most. Climate change is already very visible in all parts of the world. We are seeing more intense heat waves and drought and forest fires. We have more water vapor in the atmosphere, which leads to extreme rainfall and flooding. The warming of the ocean fuels more powerful tropical storms. Rising sea levels add to the impacts. We expect this negative trend to continue. Greenhouse gases are at record levels, locking in temperature increase for the next few decades, at least. In addition to climate change mitigation, adaptation is a top priority. Early warning systems are a powerful way to adapt. Last year, a WMO report showed that the number of disasters has increased fivefold in the past 50 years. There were more than 100,000 disasters, one per day, in total 2 million deaths. The economic cost has soared. Thankfully, casualties have fallen. We are better at saving lives. Supercomputers, science and satellites have increased the accuracy of our forecasts. Mobile phone alerts and weather apps can reach remote areas. WMO is promoting impact-based forecasting of what the weather will be and what it will do, but much more remains to be done. Only half of the 193 members of WMO have multi-hazard early warning systems and are able to forecast the impact of the weather. There are big gaps in weather and hydrological observing networks, especially in Africa, in Pacific and Caribbean islands. This undermines local and global forecasts. WMO has therefore created a financing mechanism known as SOF, the Systematic Observation Financing Facility, to boost investments in the basic observing systems and fill data gaps. We are a partner in the Climate Risk and Early Warning Systems initiative CRUISE, which seeks to protect the most vulnerable. WMO is also leading a new water and climate coalition to focus more attention on water-related hazards and shortages. We have successful programs on tropical cyclones, coastal inundation, floods and drought. Here in Geneva, we have joined the forces with the UN Office for Disaster Risk Reduction to form a Center of Excellence on Climate Change and Disasters. WMO supports the UN humanitarian system with authoritative forecasts. We work with the World Bank, the European Union, UNDP and the Green Climate Fund to increase funding for early warning services. And of course, WMO is active in the 2030 International Agenda on Climate Action, Sustainable Development and Disaster Risk Reduction. Our vision is to achieve resilience for all by 2030. Early warning works. It must work for everyone. It must lead to early action. With these words, I would like to wish you all happy World Meteorological Day. Thank you.
Thank you. So now I request Professor Someshwar Das, convener, SAMA, to give a brief description of activities of SAMA. So,
Thank you, Professor Raju. Let me share the screen. Is my screen visible to all of you?
Yes, yes.
Okay, thank you so much. Well, I'll briefly introduce the activities carried out by SAMA since its establishment. I know that many of the members are already aware of it, but since we have got some distinguished guests today, so I would like to once again replay this activities of SAMA carried out in the last 1 year. The South Asian Meteorological Association was established on 3rd of August 2020. It is a society of 9 member countries, including Afghanistan, Bangladesh, Bhutan, India, Maldives, Myanmar, Nepal, Pakistan, and Sri Lanka. Our vision is sharing knowledge of weather and climate without borders, and the mission is meteorology for the sustainable development of the region. The objectives of SAMA are foster interaction amongst professionals working in meteorology and allied fields in South Asia, advancement of meteorological and allied sciences in South Asia, application of meteorology and allied sciences for the sustainable development of the region, communicate knowledge of climate change and extreme weather events to the public through citizen science and outreach programs, and promote public, private, and academia partnership for the promotion of the meteorology and its societal applications. SAMA is registered as a non-profit international scientific society in India, having its headquarters at New Delhi on 7th of March 2022. And this is one of the milestones achieved by SAMA. SAMA is guided by advisory committee from all the member countries and driven by executive support team. We framed the constitution of SAMA last year. That was another milestone achievement of SAMA. We developed the website for SAMA. We have started publishing the annual, quarterly newsletter of SAMA. We are trying to bring many like-minded organizations to one platform. We have been conducting almost monthly webinars, and presently we have got about 321 members, including live members and also the student members. Well, these are the list of activities that was conducted in 2022. I'm not going to read out everything, but since it was established in August 2020, so we conducted only 3 activities in 2020. Then in 2021, we had 6 activities, and I mean, whole of the year. Of course, you know, the entire 2021 and also most part of the 2020, we had this lockdown due to the COVID. So all these activities have been conducted, you know, online, and also the fact that SAMA doesn't have any source of funding as of now. So all the activities that have been conducted is without any source of funding. And these are the list of activities that we have conducted in just 3 months of 2022. Starting from January this year, we had the first meeting of the scientific committees. SAMA has formed 6 different scientific committees, including education and outreach, numerical weather prediction, satellite meteorology, radar meteorology, air pollution, and climate change, to help or to make the capacity building in the member countries, and also try to help the needs of the member countries in these fields. We conducted a quiz contest in the beginning of this year for the school students of the standard 9th to 12th. And the quiz was started on 22nd of February and it ended on 25th of March, just 2 days ago. We had made the quiz open to the students of all these 9, 10, 11, 12 classes. It was open round the clock during the entire period, and the student could participate in the quiz anytime of their convenience. Quiz was co-sponsored with Vigyan Prasar and Vidyarthi Vigyan Manthan of the Government of India. Then in February, 28th February, we conducted a webinar on the works of the Nobel laureates. This is third time probably in which the Nobel Prize was given to the scientists who were working in the fields related to atmospheric science, meteorology, weather and climate. So we conducted the seminar on the works of Professor Manabe and Professor Hasselman on 20th of February. Then, as I said, SAMA was registered on 7th of March. Then we had a meeting of the first scientific committee of SAMA, that is on education and outreach. That was on 28th of March, just last week. And today we are celebrating the World Meteorological Day on 27th of March. And then upcoming activities are like, we'll have a fourth advisory committee meeting on 3rd of April, and that will be followed by the third general body meeting and the formation of the first council of SAMA. So these are some of the brief activities. And as I said, we have already started publishing newsletters of SAMA. We are there on the website. This is our address of the website, also on the Facebook, on the Twitter, and also on the YouTube channel. This program is being live streamed on the YouTube. Then there are some of the highlights of the future plans. Registration of SAMA is already completed, and we are going to have a bank account soon. It is in process. Exploring funding resources for conducting regional programs, encouraging the member countries to establish country-wise chapters of SAMA, monthly webinars on topics of regional importance to be continued. Recently constituted scientific committees for satellite meteorology, I have already listed them. They will develop capacity building programs for research and development of the region, conducting need-based training workshops for the member countries to improve their meteorological and hydrological services, explore the possibility of partnership with more regional agencies in addition to EC mode and RIMES, which are our current corporate partners, develop linkage of SAMA with other international agencies in this field, such as IFMS, that is the International Federation for Meteorological Society, the European Meteorological Society, the WMO, etc. Develop regional research projects, mentorship to young researchers and students by senior scientists, work with national meteorological and hydrological services, regional associations, and civil society in promoting application of meteorology for public safety and societal benefit. Societal applications in the climate change, agriculture, aviation, energy sector, and engage private sector in promoting applications of new technologies in instrumentation and software in meteorology. So this is just a glimpse of one of the meetings that we had, third advisory committee meeting of SAMA. And that's it. Thank you so much for your attention.
Thank you, sir. Thank you very much for elaborating the activities of SAMA since its inception and also future plans of SAMA. So now the next agenda is, now I invite Dr. Rohini to introduce today's chief guest of the event and also eminent speakers. Dr. Rohini, over to you.
Good morning, all. It's an honor to have such dignitaries on celebrating the World Meteorological Day today. Our chief guest today is Dr. Ravichandran. He's currently Secretary, Ministry of Earth Sciences, India. He worked as a scientist in IITM, Pune, at NIOT, Chennai, in COIS, Hyderabad, before joining NCPOR. He was Director, NCPOR, Goa, from 2016 to 2021. Dr. Ravichandran is the Vice President of the Scientific Committee on Antarctic Research of International Science Council. He is also the Council Member of International Arctic Science Committee, Alternate Delegate India, Scientific Committee on Antarctic Research, Indian Representative, Council of Managers of National Antarctic Programs, Alternate Delegate India, Antarctic Treaty System. He is member CBER, Scientific Steering Committee from 2010 to present. He received the MOES National Award of Excellence in Polar and Ocean Research for his contributions to the Indian Argo Project and ocean modeling. He was co-chair Indian Ocean Panel of Goose Clivar Climate Research Program of WCRP 2012 to 2016, member International Argo Steering Team and Regional Argo Coordinator for the Indian Ocean 2005 to 2017. He has an education of MSc and PhD both in physics. His research interest is in atmospheric physics and ocean dynamics, ocean observation systems, in situ and satellite, and ocean modeling and data assimilation. He is the author of more than 100 research papers published in peer-reviewed national and international journals and 3 book chapters. He is the editor of Pre and Applied Geophysics, Atmospheric and Ocean Sciences. Our first distinguished speaker is Dr. Sanjay K. Srivastav. He is presently the Chief of Disaster Risk Reduction at UN Economic and Social Commission for Asia and the Pacific, ISCAP. He was ISCAP Regional Advisor on the Disaster Risk Reduction, Head of SARC Disaster Management Center, New Delhi, Deputy Program Director of Disaster Management Support Program at ISRO, Scientist and Engineer /Engineer at ISRO, Headquarters, Bangalore. He is the recipient of ISRO's Team Excellence Award in 2008-9 for his contributions towards harnessing space technology applications for the benefits of rural poor. His PhD is in applied physics. He has more than 100 publications on disaster risk reduction, including research papers in peer-reviewed international journals, intergovernmental reports, and books. His areas of expertise include early warning systems for hydrometeorological disasters, ICT and space applications for disaster response and risk assessment, post-disaster need and damage assessment for recovery planning, integration of disaster risk reduction in climate change adaptation, mainstreaming disaster risk reduction in sectoral developmental planning, and indigenous knowledge for disaster risk reduction. Dr. Sanjay has been a lead author of ISCAP's flagship publication, Asia Pacific Disaster Report. Our second distinguished speaker is Professor A.S.M. Maqsood Kamal. He is the director, he is the Pro Vice Chancellor of University of Dhaka since June 2020. Professor Kamal is the founder chairman of the Department of Disaster Science and Management and the Dean of the Faculty of Earth and Environmental Sciences of the university. He joined the Dhaka University as a lecturer in 2000 and was promoted to professor in 2010. He worked as an urban risk reduction specialist and earthquake and tsunami preparedness expert at the United Nations Development Program and Comprehensive Disaster Management Program initiated by Disaster Management and Relief Ministry. He is also a member of National Committee for the Earthquake Awareness and Preparedness Expert Group and SARC Disaster Management Council. Professor Kamal worked as a scientific officer in Bangladesh Space Research and Remote Sensing Organizations. Presently, he is the president of the Bangladesh Society of Geoinformatics and General Secretary of the Geological Society of Bangladesh. He is also an UGC nominated syndicate member of private-run Manarat International University. He also served as the provost of Master Da Surja Sen Hall for 2 consecutive terms. His PhD is in engineering geology from Tokyo Institute of Technology. He has been intensively engaged with classroom teaching, academic research, and development expertise over multiple sectors through consultation and professional service work. Our next distinguished speaker is Dr. M. Mohapatra. He is currently the Director General of Meteorology, India, Meteorological Department. He is the permanent representative of India with WMO and elected as member of Executive Council WMO. He headed Regional Specialized Meteorological Center for Tropical Cyclones during 2014-19 prior to becoming DG IMD. He has 28 years of experience in meteorology. He has made significant contributions in improvement of cyclone warning services of IMD. He is popularly known as the Cyclone Man of India. He has received a number of awards and recognitions, including Honorary DSc from FM University Odisha, Honorary DSc from KIIT University Odisha during 2020, Fellow Indian Meteorological Society 2019, Certificate of Merit for Young Scientist Award 2018 by MOES, 25th Biennial Mosam Award, Commendation Certificate from DRDO for contribution to Integrated Guided Missile Development Program, Bharat Gaurav Award 2019 by Jai Bharat Foundation Odisha, felicitation by Shri Naveen Patnaik, Chief Minister Odisha in 2019, Satya Sai Sanman 2019 by Satya Sai Charitable and Education Trust Odisha, Bhumiputra Sanman 2020 by the Bipal Bhai Behra Chandrakar Smruti Sansad Odisha, commendation certificates from various organizations for prediction of cyclone, publication and documentary of live profile and contribution to cyclone warning services in various press and electronic media. He has MSc and PhD both in physics. He is the author of more than 100 research papers published in peer-reviewed national and international journals. He has edited 3 books, 5 journals, and 15 international reports. Our next distinguished speaker is Dr. Pema Gyatsho. He is the Director General, International Center for Integrated Mountain Development, IC Mode, Kathmandu, Nepal. He has also served the Royal Government of Bhutan as Minister of Agriculture and Forest. His appointment as Director General marks his return to IC Mode. He worked previously with the center, both with the governing board as the representative and observer of Bhutan, and in a senior level position during which he traveled throughout the region. Dr. Pema was a member of the Planning Commission, Sustainable Development Secretariat, Center for Bhutan Studies, Forestry Development Cooperation Board, and founding co-chairman of Bhutan Water Partnership. Later, he was promoted to the Deputy Secretary of Policy Planning Division, Ministry of Agriculture. He became the Deputy Resident Coordinator of Helvetas Swiss Intercorporation. He was appointed the first Minister of Agriculture and Forest in the Democratic Government of Bhutan 2 times. Dr. Pema was appointed the opposition leader in NE for the second legislative session and also elected as the new DPT's party president. In 1990, he took MSc Agricultural Honors from New Zealand, and in 1996, he took PhD from ETH Zurich. He's currently reading research on climate change and cities. His research work focuses on climate adaptation and climate action in Indian cities. Last but not the least, we have our distinguished speaker, Dr. Mandira Shrestha. She's a program coordinator, climate services, Mountain Environment Regional Information System, MENRIS, at the International Center for Integrated Mountain Development, ICMOD. She has over 25 years of research and consulting activities that cover broad areas of climate services, water-induced disaster risk reduction, and water resources management. She served as the executive secretary of HKH Friend and UNESCO program and coordinated all activities with international and regional collaborating institutions. She has coordinated the development of a web-based regional flood information system in the Himalayan region, where the countries are sharing real-time data and information for flood risk reduction, thereby strengthening regional cooperation. She is leading the transboundary flood risk reduction programs, promoting dialogue and strengthening hydromet capacity in the region. Dr. Shrestha holds a doctorate in engineering from Kyoto University, Japan, an MSc in civil engineering from University of Washington, and a bachelor's on civil engineering from University of Roorkee, now IIT Roorkee. Her research interests center on transboundary flood forecasting and monitoring, application of satellite-based products, early warning systems, and end-user engagement for reduced risk and increased resilience. Her current research focuses on localizing climate services for agriculture and tourism, communication of early warning to the last mile, and institutional capacity building in future climate change projections. Dr. Shrestha has an excellent professional network with donor agencies and partner organizations in the region. Thank you very much.
Yes, thank you, Dr. Rohini, for giving this detailed introduction about this today's distinguished guest and speakers. Now I request our chief guest, Dr. M. Ravichandran, Secretary, Minister of Earth Sciences, Government of India, to deliver a keynote address.
Thank you, Dr. Raju.
Can you stop sharing the screen, please?
Rohini,
Dr. Air Vice Marshal Dr. Ajit Tyagi, Chairman of South Asian Meteorological Association, Dr. Mahapatra, Director General, Indian Meteorological Department, Dr. Someshwar Das, Convener, South Asian Meteorological Association, distinguished speakers and members of SAMA and IMS and other participants. A very good morning to all of you and greetings to all on World Meteorological Day celebration today. As you all know that the theme of WMO 2022 is early warning and early action. Under this, now SAMA is organizing hydrometeorological and climate information for disaster risk reduction. I am very happy to note that SAMA, consisting of 9 South Asian countries like Afghanistan, Bangladesh, Bhutan, India, Maldives, Myanmar, Nepal, Pakistan, and Sri Lanka, have jointly come forward along with the Indian Meteorological Society to celebrate World Meteorological Day on this theme. Thank you for making such an effort, and it is very important and need of the hour. As you all know that the South Asia is highly prone to weather and water-related disasters, such as flooding, drought, thunderstorms and cyclones, inundated deltas, parched plains, eroding beaches and riverbank, the impacts of which often transcend national boundaries. South Asia experiences every conceivable weather and weather-related disasters, starting from lightning to long-term sea level rise. You take us in time scale or spatial scale. The smallest one is such as lightning, as well as the longest time scale of sea level rise. All things are happening in this region. Also, the high population density compounded the problem with the many people are at highly regular risk. Climate change is now adding significant additional risk to this already volatile disaster situation. The signs are everywhere is happening. It is amply clear that the possible consequences of the global warming and climate are spreading to all spheres of life. Climate change will have adverse impacts over many parts of the globe. In the changing climate scenario, the demand for weather and climate services by the society has increased many folds. This is because many production systems in different areas of technology want to explicitly account for weather and climate-based vulnerabilities in their planning strategy. From all three spheres, such as atmosphere, hydrosphere, and cryosphere, we need to understand and warn early so that action can be taken swiftly. When we talk about atmosphere, it is happening, the extreme rainfall, lightning frequencies are increasing, flood in one place, somewhere it is occurring flood, another place it is occurring drought, heat waves are occurring. So many things are continues to increase in the global warming scenario. So we need to be better prepared. For that, we need to warn the society much ahead. As IPCC recent report pointed out, human-induced climate change, including more frequent and intense extreme events, has caused widespread adverse impacts and related losses and damages to nature and people, beyond natural climate variability. Some development and adaptation efforts have reduced vulnerability. Across sectors and regions, the most vulnerable people and systems are observed to be disproportionately affected. The rise in weather and climate extreme has led some irreversible impacts as natural and human systems are pushed beyond their ability to adapt. Hence, it is imperative to have a multi-hazard early warning system to take care of weather and climate-related hazards. Once the warning system in place, the next task is to plan to early actions. So that is the theme of the WMO this year. When come back to ocean, the upper ocean continues to warm, and because of warming, it inhibits the vertical mixing due to both the thermal stratification and salinity stratifications. And we monitor only half of the ocean volume up to 2000 meters. Below 2000 meters, we don't know what is happening. Of course, there are many changes. The primary changes in the oceans are upper ocean warming, also the oxygen reduction, and maybe the ocean become more acidic. When we talk about ocean warming, it is not only the stratification is causing a problem, but also the heat content in the upper ocean and the SST increasing, SST and other things has many consequences in the atmospheric and weather phenomena. In the long term, the sea level rise continues to mold in the Indian Ocean, especially both steric and water mass continue to increase in the global, but in the Indian Ocean, the steric contribution is much more. And also there is a lot of variability it is happening in the Indian Ocean. And because of this warming, there are coral bleachings are happening. So the warmer waters cause coral bleaching, which in turn impact coral reef ecosystem that are home to array of marine biodiversity and provide crucial sources of food for the people. When the oxygen depletion is happening, as you all know that the North Indian Ocean is prone to oxygen minimum zone, the harmful algal bloom and the fish disease and other things bound to happen. Of course, ocean acidification is another important things are happening due to warming world. Species also on the move and the diseases are happening in the ocean. Warmer waters threaten to cause mass migration of marine species in the such of right condition for feeding and spawning. The tropical species is migrating to mid-latitude, and the mid-latitude species are migrating towards the poles. So the ecosystem shift is happening. Change in water temperature can directly affect the development and growth of most of the fisheries. You all know that ocean currents is also changing in the long term, and also the upwelling zones are also changing, and it will have a direct and indirect impact. Ultimately, the weather pattern changes. So that is why some place it is a fire and some place it is a flood is happening. For the 3 billion people who rely on fish as their chief source of protein, the prospect of fewer and smaller fish in the seas is a bad news. Rising ocean temperatures are driving unprecedented changes in the global marine ecosystems like sea levels and weather patterns. As heat transforms the ocean, threats to food supplies, economics, and weather multiplies, putting human and environmental health is at risk. Hence, we need to better prepare. For that, we need to observe, understand, and finally forewarn the changes to the policymakers to make immediate quick actions. The other sphere, it is a cryosphere that is also changing very rapidly. The increase in air temperature, both at the surface and aloft, is highest in the polar regions, especially in the Arctic. The dramatic reduction in summertime sea ice extent is happening. Loss of multi-year sea ice and reduction in mean thickness is also happening in the polar regions. Increased upper ocean freshwater content is also going on increasing, and the ocean heat also is enhanced in the recent decades. Of course, the amplified ocean acidification and the ecosystem shift also is happening in the polar region. All you know that the accelerated Greenland ice sheet melting is an immediate threat to the global sea level rise. And also the warming permafrost adding to the greenhouse gas effect. And yet we need to understand the polar teleconnections. We have a strong teleconnection between the tropics and poles, especially in the Arctic. The extreme rainfall happening in the northwest India as well as in the Pakistan area, it all the way, the heat released from the atmosphere, it all the way goes to the Arctic, and the sea ice melt is happening much more there. And then once the sea ice melt is happening, more open water then absorb more heat, and then it is having another impact towards the tropics. So there is both in the intra-seasonal time scale as well as in the long-term time scale, there is a strong relation between the tropics and the Arctic. Of course, you all know that in recent days, the Antarctica too is warming much more. I think last week you might have seen 40 degrees centigrade above normal as observed in Antarctica, especially in the eastern Antarctica in the mainland. Of course, the Southern Ocean is also warming continuously, and because of the westerly winds in the Southern Ocean is go on increasing, and thereby the Southern Ocean warming, and it is having a serious consequences. The Southern Ocean warming will have a pressure gradient between Musker and High, and in India land will be reduced, and thereby the equatorial cross flow also will be reduced. So there will be an impact. So, and finally, the Himalayan glaciers also changing. As you all know that the Western Himalaya, the glacier melt is happening much more than the eastern side. So it is having a larger impact in the more than 2 billion populations depends on this Himalaya. So the atmosphere, hydrosphere, cryosphere, all will have a combined effect of climate change, and eventually the biosphere too affect. We need to understand them better for forewarn at various time scales. For that, collaboration is the key. We, among South Asian regions, work together to generate knowledge and data and information sharing for the benefit of society at large. Also, we need to build the capacity in our regions for further strengthening and promoting meteorology and its allied sciences and applications at large. Considering this, South Asian Meteorological Society one-day event will provide a common platform to bring together atmospheric scientists, research professionals, policymakers, disaster manager, and other related experts to discuss and share. I am sure at the end of this workshop, few recommendations will be made, especially weather and climate services related to early warning system for better preparedness by the society. I convey my best wishes for the success of the workshop. Thank you one and all. Thank you for giving me the opportunity. Thank you.
Thank you very much, sir, to enlighten the impact on ocean ecosystem on extreme weather events and importance of early warning system, and also the capacity building over the South Asian regions. So definitely Sama will work on these aspects of the future plan. So now I request the first distinguished lecture by Dr. Sanjeev Srivastava, UNESCAPE, Chief Disaster Risk Reduction. He is going to talk on prospects of impact-based informed early warning to enable early actions. So I request Dr. Sanjeev Srivastava.
Yeah.
Yeah.
Yeah. Thank you very much, colleagues. Thank you for giving this opportunity. It's an honor and privilege to speak in front of the top scientists, scientific community of South Asia. Many of them I know personally. They have been my friends, and I thought this is the opportunity to share with you the early warning and early action from a slightly different perspective. Some of the perspective WMO Secretary General has highlighted in his speech. Let me share with you from the lens of sustainable development, how important this early warning and early action is. Last week on 10th of March, we launched Sustainable Development Goal Report for Asia and Pacific, a region which has been hit very hard by pandemic in midst of many other disasters in the regions. I would like to bring to your highlight that this South Asia region, in ISCAP, we include Southwest, some part of Iran and Turkey as well. But what is important to bring to your attention is absolutely not on track to achieve any of 17 Sustainable Development Goals by 2030. And the biggest spoiler in the process was the pandemic in the regions. But what is of biggest concern is a regression trend on climate action that is called SDG 13 is a cause of concern worldwide. Many people, they say that pandemic has got the vaccine and now the recovery has started, but the climate change has no vaccine. It's so immediate. You need a very different kind of strategy. So what is the real strategy? When you see in the left-hand side, the regression of climate action has many implications on climate sensitive sectors or sustainable development goals. So the key action that is suggested, a strengthened resilience and adaptation of climate related disaster, that is particularly very key for South Asia. The solution lies in managing climate risk through more efficient and effective hydrometeorological services. I don't have to say you are all expert in this area. And this is where the South Asia Meteorological Association has to play a historically important role in coming days. What I want to bring to your attention is, because I come from the Economic Commission of United Nations, we did an assessment how much is the loss due to disasters, direct, indirect, across the multiple sectors. And what I want to bring to your notice is, you see in South and Southwest region, the annualized average losses are $153 billion. It's called risk escape, land escape of disaster risk in South Asia. And the largest contribution to these losses come from the drought. Most of the economic assessment of the drought, they just take the loss of agricultural production, some sort of livestock. Here, what we have taken is the intersectoral, direct, indirect, visible, invisible impact of the drought. So when you see the climate risk contributes to $153 billion per annum in South Asia. And that is not sustainable for many of the goals and targets for a resilient South Asian regions. I would like to tell also to pin down that if you see the countries of South Asian region, which country has highest annualized average losses? And what has been seen in present analysis, this recently came in our Asia Pacific disaster report. Climate hazard is not alone. It has intersectoral implications we call disaster, climate, and health nexus. So when you take the impact of disaster also on health sector, in addition to the economic sectors, these impacts in terms of money is much more. The health sector alone contributes to $7.7 billion per annum losses. And you see the country, of course, India, maybe because of its size, and then rest of the country are here. You can see the methodology on the screen. But then what Professor Petripelas told in his statement is, what could be the possible solution for adaptation to disaster risk? And what you have seen, what the Secretary Ministry of Science has highlighted is the changing climate, but in a specific context of South Asia, where the solution lies. And when you see this is, we have developed a radar diagram of adaptation metrics in a specific context of South Asia, derived from its climate risk profile, is much more scientific way to bring out the adaptation metrics, which comes from the climate risk profile of a sub-region of a country. And you see where the largest benefit cost in South Asia is, it's on multi-hazard early warning system. A strengthening early warning system has highest benefit cost ratio. It also contributes to many of sustainable development goals, and then goes to the resilient infrastructure. So these are the two key adaptation priority, which can really strengthen, leapfrog the resilience target of South Asia. Coming to the subject of today's discussion, this is one example I would like to share with our UN Resident Coordinator Office of Bangladesh with UN OCHA. What this early warning, early action does fundamentally, the key fundamental reason why we should attach so much priority to it. You see the traditional response to disaster. Traditional response, the left-hand side, when you see there is a steep curve upwards of the humanitarian crisis, and that crisis is a very wide envelope. It goes to the peak, continues for large number of time. And then accordingly, you mobilize all your resources. But what impact forecasting or early warning and early action does it helps to trigger anticipatory action. And this anticipatory action forecast based with action plan, including pre-arranged financing, it flattens the curve of what is called the distress curve of the humanitarian crisis curve. And you see how it flattens down. This has been seen on the ground in Bangladesh. And based on this, a multi-hazard early warning, early action approach, how it flattens humanitarian crisis is seen, particularly in monsoon floods in Bangladesh case. Now, I would like to bring to your attention, because many of the discussion today has taken the recent IPCC Assessment Report 6, particularly the first, the physical science. The risk in present context is not that simple. So most of our mechanism of early warning system were based on the paradigms as a hazard, including the climate hazard and the vulnerability people on the ground. And then there are exposure of infrastructures, the cities, settlements, ecosystems. And then based on this, you develop your response pattern. So response is a very linear way of thinking. And this is what most of the disaster response strategy developed in the past. But what is happening today is hazard is not simple. There is a interaction of drivers between the dominant part of the risk. Hazard itself is interacting in vulnerable, there is an interaction, vulnerability, and then risk. But what is specifically I want to point out to your attention is category 3. This is a new norm. Category 3 is a aggregate and cascade. Cascade is You see the third part, last one. For example, drought, which leads to heat waves, and that leads to the diseases. So that's the cascade. So it is an example of disaster, climate, and health nexus. So any impact forecasting that you develop, if that impact forecasting doesn't capture this nexus, it may not be adequate. Compounding risk, cyclone, storm surge, landslide. I would like to quote, I'm happy Dr. Mahapatra ji is here. Cyclone Titli in Odisha, I think 2018, it was a perfect, a very precise early warning system, forecast of intensity, track, landfall, everything point blank. But still, around 28 people died. They died not because of the tropical cyclone intensity landfall, but because of the landslide, which triggered later. So these are what is called the compounding impact. So the early warning system for early action must address this complexity of the risk, which are going to be much more in days to come. Here, I would like to highlight what we have done in UN, particularly with many of our partners, including IMD Pune, Regional Climate Center, RINES, and WMO office in Singapore. You take the climate services, global framework of climate services approach, take the hazards, exposure, all is listed here, population, agriculture, health, and vulnerability, and then take impact. So impact, when you are taking, it's cascading impact, it's compounding impact. So this is something which captures a wide canvas of what is called impact-based risk-informed forecasting. And this is something which fills in many gaps which exists today because of the linear understanding of hazard, vulnerability, risk, and exposure. This is a global framework for climate services. It has been part of many of the government's work, including the work of IMD in India. But putting this in action requires many technical or institutional capacity. I would like to share with you what we did, particularly with one example. Impact-based forecasting from a disaster manager perspective, the community which I belong to, it has to be a very tangible and something very actionable second generation early warning system. For example, this forecast must pinpoint at-risk community, how many people, where they are at the risk. From the people, children, adults, elderly, and then urban, rural. The same impact should also cover the at-risk economy, the economic assets at risk. What is the monetary value of this? So all this has to be part of the impact forecasting. This, what we did with IMD Pune, we use the SASCOP product. We use the SASCOP product, particularly the last time SASCOP, it was October, November, December, and use this in conjunction with the traditional hazard maps, the flood and drought. And then what came out very clearly is the impact map. The impact map is how many people are going to be at risk in South Asia. And you see those people are targeted in coming seasonal October, November, December of 2021. This part of the people will be at risk of floods, drought, and that's how you can target your actions. This is the early warning and early action. Of course, the probabilistic forecast has its own limitation, but this is an important step in the right direction. You see the number of people identified, where they are located, to what percent of the population in the country. So this is what is called, in a true sense, impact-based forecasting. Just to bring to your attention that we did this exercise in 2020, that is June, July, August, SASCOP product. And it's not something, a big tall claim, but there was a indication of the flood in Karachi in part of Pakistan in August 2020. 2020, and it was captured in seasonal forecast and what was seen on the ground. So at least there are some element of what you can visualize through seasonal forecast and what could be seen on the ground. So my next part is what is at risk of the ecosystem. So seasonal forecast on the ecosystem-based maps will give you the ecosystem which are likely to be at risk in the monsoon season. So that helps you to take early action. The third from, you see, this is what is pinned down, the ecosystem to be watched for. Same agriculture. Which part of agricultural system is likely to be impacted in the coming monsoon season? You see the impact zone, which are like a hotspot in coming monsoon season in Afghanistan, India, Sri Lanka. And this, the more important part is when you are pinning down, you highlight this. Agriculture is a very important sector of the economy. So the impact of monsoon will be very severe in the economy. The third part is the part on the water, in the global framework summit, the at-risk water, which are the part of the region Asia Pacific, which are already water deficient, and then there is going to be a shortfall of the rain. So that will create additional water stress. So pin down those areas for interventions in months to come. This is another important is the energy at risk. Many of the hydroelectric power plant in the regions depends on the quality of the monsoon rain. And you use the impact forecasting to pin down which hydroelectric power plant and what is their capacity in countries' energy security, how much important is this. For example, in case of Nepal, close to 90% Nepal, Bhutan hydroelectric power plants contributes to the energy security. So those particularly in monsoon context will give a lot of idea about the possible intervention. My last point is impact on the health. So this is driven by many of the weather-related factors, including dengue. So when you use seasonal forecast for the interpretation of the health, there are many limitations of it but still you can pin down to some extent broadly the outbreak of dengue in different parts of South Asia this is just the interpretation of SARS-CoV product in conjunction with many other risk and vulnerability information. We have brought a manual. We work this for WMO. Is a part of our CREW project, which Secretary General WMO was referring to. So, and this is how it can be done, how climate, particularly global framework of climate forecast can be brought up. This is the last slide to show you. These are all the data which we have, particularly the population gridded form of data. It's all what I have shown to you. We have put in place in form of a digital database, including your adaptation and risk profile, which may help to contribute to impact-based forecasting, early warning, and early action. So thank you very much once again for giving me this opportunity, my colleagues. Thank you very much.
Yeah, thank you very much, sir, for giving this detailed talk on impact-based forecasting system and early warning on the global framework of climate services, so which are very important for the disaster risk reduction over these regions. Thank you so much. Move on to the next speaker. I would like to invite Dr. ASM Maqsud Kamal, Pro Vice Chancellor of Dhaka University of Dhaka, Bangladesh. He is going to talk on effectiveness of early warning system for the hydrometeorological disasters in Bangladesh. Over to you, sir.
Do you hear me?
Yes, yes. Can you put the full screen, sir? Yes, yes. Now it's okay, sir. Yeah.
It's okay?
Yeah, please.
Okay, thank you. Thank you, Dr. Raju. And also I would like to offer thanks to SAMA as well as Indian Meteorological Society to invite me here in this event. This is, is a program to address the World Meteorological Day 2022. And the main slogan of the day is the early warning, early action. We came to know particularly from Dr. Sanjoy Shabista regarding the benefit of early warning and early actions, and how early action reduces the sufferings and vulnerability of the community who are at risk. I would like to give you a snapshot on the effectiveness of the early warning for the hydrometeorological disaster of Bangladesh. When we are talking about the effectiveness of the early warning, it means 4 components. One is the risk assessment, that is the systematic collection of the data and undertake risk assessment. The second one is the monitoring and warning service, that is the development of the hazard monitoring, continuous monitoring of the hazard and early warning system. And later on, this is the dissemination and the communication. It means to disseminate the early warning system to the community who are at risk, and then the capacity of the government, of the national and the subnational organization in order to address the early warning during the period of emergency. So these are the 4 elements which comprises an effectiveness early warning system. And once we develop the scientific documents, but it's not propagated to the community at risk, then there is no value addition to reduce the risk of the communities without proper dissemination of the early warning. Since this is the effectiveness of the early warning, I am letting you know regarding the topography of Bangladesh. Bangladesh, this is about 50% of the country is within 6 to 7 meters of the mean sea level. Then around 68% of the country is vulnerable to flood. 20 to 30% of the area is inundated during the normal flood. Coastal area varies from 0 to 5 meter mean sea level. We have around 310 rivers in the country, among which 57 rivers comprise of the transboundary, and out of which 54 came from India and 3 from Myanmar. So this is the topographic scenario of Bangladesh. And if we see the hazard profile of Bangladesh, we do experience mostly the cyclone and the flood hazard in our country. Almost in every year, as I mentioned in the previous slide, around 30% in normal flood, 30% area of the country got inundation. And cyclonic event, we do experience frequently the cyclonic events, almost a big cyclone, what we call the super cyclone, every 10 years interval we do experience. Beside the cyclone and the flood, Bangladesh recently experiencing the landslide hazard, thunderstorms, and etc. But I will focus particularly on the cyclone and the flood hazard early warning system of the country. When we are talking about the disaster management cycle, then it can be divided into 2 parts. One is the risk assessment, another is the crisis assessment. Early warnings, it's belong to the part of the risk assessment, and based on the early warning, as our main slogan of the World Meteorological Day 2022 is the early warning and early action. If it is possible to address the early warning, then it's as I mentioned before, the national and subnational agency and the community actors, they could have the proper preparedness, and then it's possible to reduce the damage and loss of the national and subnational scale. And for that reason, early warning, of course, is the prime element to reduce the vulnerability and to reduce the life and to reduce the risks of the life and livelihoods of the community. Early warning in Bangladesh. The main agency were involved in hydrometeorological to provide the early warning in our country for hydrometeorological disaster is the Bangladesh Department of Meteorology, and to certain extent Bangladesh Space Research and Remote Sensing Organizations. And this, as both the agencies belong to the Ministry of Defense. Then, in order to provide the early warning for flood, the Flood Forecasting and Early Warning Center is the responsible organization. It's belong to the Ministry of Water Resources. And both the agency provide the early warning information to the Ministry of Disaster Management and Relief, particularly to the Department of Disaster Management of the Ministry of Disaster Management and Relief. And then early warning systems are early warnings are disseminated to the all all partners located in the national and subnational scale. And here is some idea related to the early warning of cyclone. In our country, in order to produce the early warning of the cyclone, then the data or the information we do gather is the surface weather chart every 3 hours or more frequent, upper air pilot chart every 6 hours, upper air constant pressure chart every 12 hours, pressure and temperature change chart 12 hours and more frequent, and relevant other atmospheric behavior as frequent as required. Then our meteorologists work on it and develop the interference of the scenario, what to happen. And then another information, what type of satellite information our Department of Meteorology and the academic institution usually gather. Academic institution provide support to the ministry, to the Department of Meteorology when required. Our Met department usually use the Himawari satellite images of Japan, then FY2D and FY2E satellite of China, then near real time other satellite images and product from different satellites from through internet, then INSAT and Kalpana images from Indian Meteorological Department website, and BMD's radar images. We have around 4 Doppler radar around the country, and conventional radars also. Then meteorologists provide them, develop the modeling in order to develop the early warning. Here is the model information, WRF model product, and then numerical weather prediction output from different centers across the globe. We do use the storm sub model. It is the IIT Delhi model running at BMD also. Then MRI, the model of Japan Meteorological Association, StormSat and web model. Afterwards, we developed or our scientists developed the interference to get the early warning of the cyclone. And preparation and forecast of the early warning, there are 4 steps usually. Then steps 1 is the data or information collection. Step 2, analysis results from the meteorologist, then experts justification and future of the atmospheric condition. And we get the summary. After that summary is related to the climatology and behavior of the system, atmospheric system, and then forecasting and warning systems are delivered to the organizations. The organizations, particularly the Ministry of Disaster Management and Relief and the Department of Disaster Management, are responsible to disseminate the cyclonic early warning system to different agencies. And in Bangladesh, in the ground level, we have the cyclone preparedness program, and around 76,000 volunteers are working in the coastal area. In the coastal area, around 22 districts are highly exposed to the cyclone. And there, the cyclone preparedness program volunteers used to provide early warning system to the community with their different type of activities. And this is the how the volunteers want the scientific informations are provided to the cyclone preparedness program volunteers. Then they engage themselves in order to provide the early warning in order to avoid the people who are at risk in the coastal area. And this is one of the slide how cyclone preparedness program works. It works from the from sub-district, which is called the Upujela. Then it works in the another administrative unit we call the union, and then in our country more than 3,000 unit we have the cyclone preparedness program volunteers, and these volunteers then hoist the flag in order to avoid the people when there is signal 1 to signal 3, then one flag is hoisted. Then when when from signal 4 to signal 7, then they used to raise 2 flag, and then from 8 to 10, it's 3 flag are usually raised. Particularly, this flag are raised in the locality where there are some sort of gathering of the people. And now another information related to the flood warning system. As I mentioned before, that in our country we have around 310 rivers, and within the river system there are 343 hydrological data collection point, and among the 343, then flood monitoring station we have right now 94, real-time flood forecasting station we have at present 55, and real-time data collection related to the water level of 94, and rainfall station we have 70. Based on this information, then model-based flood forecasting systems work. This model-based flood forecasting system usually now we do use Mike 11 for model-based for flood forecasting system. And this slide forecasted hydrographs are developed, and based on the forecasted hydrographs, it is mentioned the flood maps. And this is the typical forecast hydrograph, that is the deterministic one. And based on the deterministic one, then it's possible to aware the people what could be happening in the next couple of days in certain area of the country. And we have another one, that is the probabilistic forecasting, 10 days probabilistic forecasting. This is based on the water level of the river system. Particularly here I have shown the Jamuna River at some location. It is called the Bahadurabad. And this is the danger level. Then the average and lowest danger level is shown in the probabilistic forecasting system, which is possible to give around 10 days back of the occurrence of the event. And now flood forecasting system of the water development board is working on the 15 days probabilistic forecasting, which is based on the discharges, and 51 scenarios under this model. 51 scenarios are possible to develop, and based on the scenario, then it would be possible to provide the early warning system to the community almost in the precise way. Here is the rainfall station of the monsoon, rainfall situation during the monsoon time. And also another in the right slide represent right figure represent the community level flood risk identification. So we are providing the scientific information to the local community based on this type of flood level marked in the concrete pillar. So based on this pillar, community level people get their understanding how to evacuate themselves, where, when they should have to prepare themselves to evacuate and to go to the flood shelter. And this is the disaster and emergency response group. In our country, we have the standing order on the disaster and standing order on the disaster in this booklet. all sort of informations are provided to the disaster information focal point, how to respond from the national level to the sub-national level. And these informations are going to the district disaster management committee, then the Upajila Disaster Management Committee, Union Disaster Management Committee, and further to the local community through the internet, through the SMS, by the volunteers, and also by the local political leaders. And this is the dissemination and responses, just a snapshot how this stakeholders activities are ranked in our country. For example, in national level, it's working very nice. And then the dissemination of the early warning by radio, television, print, and electronic media, this is working also very well. District Disaster Management Committee is not that much, I would not say that it's excellent, but working good. And Upajila Disaster Management Committee, here we need to do further educate the members of the Disaster Management Committee, and later on in the Union Disaster Management Committee and grassroots level flood to educate the grassroots people here. Our experience is not that good, performance is the poor. The conclusion is like this: due to the effectiveness of the early warning system, what I have been mentioning in the first slide, that is the risk assessment, then risk monitoring, then the dissemination of the information, and the last one, response of the people who are at risk. The early warning system works like this way, and so far Bangladesh is moving towards zero casualty, due to the early warning system or proper early warning system, response based or effectiveness due to the effectiveness of the early warning system. Climate change induced early warning deserve further attention from the regional to local scale. Lack of the local location of the specific forecasting, it is still poor in our country in a specific location to provide the early warning. And later on, what has been told by many of the previous distinguished speakers, that data exchange and effective collaboration is needed over the regional partners. Thank you.
Thank you very much, Professor Kamal, for giving this elaborate on natural hazards and early warning system and mitigation over the Bangladesh. Definitely, Bangladesh is one of the having very good disaster management system because the country is facing a lot of disasters in terms of cyclones, floods, and thunderstorms. So I have a fortunate to work with Bangladesh government of meteorology and flood forecast warning center when I was in the ADPC and RAMS in Bangkok. So thank you very much for giving these details. Next, the question and answer session. Since we are delayed for 10 minutes, I request Dr. Swagata and Dr. Mohan go for quick 1 or 2 questions, please.
Yeah, thank you, Professor Raju, and thanks a lot to Dr. Sanjay Srivastava and Professor ASM Maksud Kamalji for nice and extensive details. And it is a very happy moment that the theme of WMO Day 2020 is early warning and early action. It celebrates the great achievement of national and international meteorological and hydrological services in improved of early warning system. I'm going for 1 2 quick question. One question by yourself, Professor Raju. How can university contribute and work on SDG 13 climate action plan? The question I think mean to Dr. Sanjay Srivastava. Hello, Dr. Sanjay Srivastava sir, are you there?
Yes, I'm here. Hello.
Yeah, so the question is that how can university contribute or work on SDG 13 climate action plans?
Actually, you can hear me?
Yes, sir.
Yeah.
Thank you. It goes without saying, because most of the development work if I'm referring to impact forecasting, it is quite a bit of research component. If I cite the example of, let us say, IIT Delhi, they developed a storm surge models, and through WMO SCAP panel on tropical cyclone, it has gone to the many countries. And most of the storm surge modeling is contributed by the university of the respective country. So in my request, what I highlighted in my presentation was a SASCA product, which is a South Asia regional product. If you could develop for your seasonal forecast, the short-term, medium-term forecast, convert those forecasts into the impact scenarios. And that impact scenario you can only develop if you analyze your seasonal forecast in conjunction with risk, vulnerability on real time, what Professor Kamal from Bangladesh also highlighted. If you have a risk assessment map with you, right, and that you analyze in conjunction with the seasonal forecast data, it converts, it translates your seasonal forecast into the impact scenarios. These are the area where university can play a very important role. You know, if you look at the climate action indicators, impact forecasting is one of the weakest link. And today, WMO Secretary General also highlighted, countries have many capability, but multi-hazard early warning system, impact forecasting, that capability is still quite limited. It's there in only few countries. So that's from my side. Thank you very much for interesting.
Thank you very much.
Yeah, Dr. Mohan, you want to ask?
Thank you, Dr. Shagataji. Thank you, honorable speakers. Very nicely covered many people, community-based impact assessment related warning issues. So one question comes in the chat box there. What is the difference between early warning system and public warning system? So I would like to ask Professor Maksud Kamal sir. He is also the chairman of National Oceanography and Maritime Institute, NOAMI. Sir, question is for you.
Thank you, Mohan. Do you hear me?
Yes, sir.
Okay, when we are talking about the early warning system, this is the scientific product, as I mentioned before, that this is based on the risk assessment. Then we can calculate the based on the risk assessment. Then we develop the early warning system based on the risk and based on all sort of information where modeling sort of things are related. And when we're talking about the public warning system, then this scientific product then are translated to the signals. For example, I have shown in my slide that how the CPB volunteers are working in the coastal area. They used to raise one flag when the signal is, for example, 1 to 3, that means the cautionary signal. Then they want to raise 2 flag, that is to take the preparation for the evacuation, and they raise 3 flag when the great signal. They represent the great signal. People must have to evacuate themselves and go to the cyclone shelter or go to any sort of shelter nearby. So thus early warning systems are converted to the public warning systems. Scientific informations are converted to the public warning system with some activities who people can understand easily how to respond during the period of emergency. Thank you.
Thank you, sir.
We have one more. Yeah, we have one more question from our live streaming YouTube.
Yeah, it is for ocean related. Okay, please.
Yeah, one from Elijah Suvedi. So how do humans affect on ocean acidification? It's not very directly to the early warning system, but still if anyone can.
It is related to the keynote speaker, right?
Yeah, it is related to the keynote speaker.
I think any one of you who are maybe the coming keynote speaker, they can also contribute, but this is not particularly from our side. I am not working in this area.
Yes.
Yeah, so we'll take the question again after the next session. Okay.
So hand it over to Professor Raju, sir.
Yeah, thank you, Dr. Mohan and Dr. Swagat. Now moving to next sessions, I invite my co-moderator, Ms. Chatushka, to take over this session and continue. Ms. Chatushka, are you there?
Yes, I'm here.
Yeah.
Thank you, Dr. Raju. And now I cordially invite our third distinguished speaker, Dr. M. Mohapatra, the Director General of IMD, to deliver his talk of impact-based weather forecasting for South Asia. The floor is yours, sir.
Namaskar. Good morning and good afternoon to all distinguished participants. At the outset, I congratulate Sama, Professor Tyagi, Professor Shamsud Das, and the entire organizing team for this workshop on the occasion of World Meteorological Day. I extend a warm greetings to all of you for celebrating World Meteorological Day. So I will be discussing about the impact-based forecasting in South Asia. So whether my slide is visible?
Yes, sir.
Yes. Okay. Is it moving?
Yes, it is moving.
Okay. So if you just look at the various approaches being taken off nowadays by the national meteorological and hydrological agencies, the impact-based forecasting is one of the most important approach which we are venturing into. The basic meaning of impact-based forecasting is that instead of telling what the weather will be tomorrow, we are trying to tell what the weather will do tomorrow. So, for example, if I am having a forecast for heavy rain over Kathmandu, I should say about whether this heavy rainfall will lead to flooding, lead to inundation, or will lead to transport jam, or it will lead to the impact on the slums, whether it is required for evacuations, etc. So when we think about this concept, the basic questions comes to our mind: why there is poor response, even if there is a good forecast? One of the example, my predecessor, Dr. Sanjay Srivastava, was talking about that an example of Cyclone Titli, how the forecast was quite good, but even then people died because of the landslides. So what we find that even if you have got the good forecast, sometimes it can result in poor response. So basically, if you just look at the reasons for that, what you find actually, the weather models and the hazard models are not coupled to each other. For example, if you have the tropical cyclone forecast, you should have also the storm surge forecast, the landslide forecast, the flood forecast. The models on floods, landslides, and storm surge should be integrated with the tropical cyclone forecast. Then only there can be first hazard models, then impact models, and hence the risk assessment and the impact forecast. There is also lack of scientific and technical capacity to translate hazard information into impacts. Therefore, impacts are underestimated. Usually, if you look at the forecasters in National Meteorological and Hydrological Services, they are accustomed to provide the weather forecast. They are not accustomed to provide the impact forecast. So in their mind, there is some kind of hesitation while they go for the impact forecast. They get afraid sometimes, if I give this forecast, an action is taken, and my forecast goes wrong, so what will happen? Also, they don't have some complete scientific and technical capability also to translate this hazard information into the impacts. By that way, the impacts goes underestimated. There are also inadequate communication channels which can fail during the event. Say, for example, if you have got a particular weather event, and because of that weather event, there is failure in power communications and also the conventional communication channels. In that situations, the information cannot be communicated. So impact forecast also needs an adequate communications provisions. The lack of appreciation and utilization of available vulnerability informations, so like vulnerability maps. Even though we have got a lot of data with respect to what has been happened in association with severe weather, we do not have that data digitized. As a result, we are not able to provide a historical digital map. But very often we have got the analog maps that can be utilized. But at local level, if you want to take a decision, then you need the map projections of various types of vulnerability based on the exposures, etc. And sometimes the data are there, but they are not shared and not routinely updated and not digital. So therefore, it creates a problem to integrate all the information required to have a good response. And there is no effective decision support system. When you go for a decision for whether it is quite natural, you can go for. But when you go for an impact-based decision system, you need the information about the weather, about the hazard, about the vulnerability, about the exposure, and hence the decision for impact. I'll just give an example. Dr. Srivastava has actually helped my presentation easier. He has given vividly described the various impacts in South Asia and Southeast Asia. I just want to give an example of cyclone. For example, just look at what is the loss because of the cyclone in different Southeast countries. A huge loss, and accordingly, you will find that there is need for impact. We have been able to minimize the loss of lives, but we are not able to minimize the loss of impacts so far because we do not have a realistic impact-based forecast in the region. I'll just give an example, same Titli cyclone, but Dr. Srivastava was referring. You see, we could provide a very good forecast for the track moving towards northern parts of Andhra Pradesh and then Odisha, and accordingly, actions were taken for evacuations, etc. But people died, those were taking the shelter in a cave in Gajapati district of Odisha. So as a result, those people died. So another example I want to give you, the Kedarnath episode in 2013, when there was flooding over Uttarakhand, even though there was forecast, but we could not tell what will be the impact. And accordingly, action could not be taken by the estimates in the general public, and there was huge loss in terms of property and also a number of lives. But at the same time, if you just look at taking an example of India, you will find that the forecast accuracy has improved like anything. There has been about 40% improvement in accuracy of severe weather events in the last 5 years compared to previous 5 years. There is an improvement with respect to cyclones, heavy rainfall, thunderstorms, heat waves, cold waves, and whatnot. And then what is done then? So what we need therefore that we have to move in South Asia from a simple forecast into the impact-based forecast. We have to move from simple observation, forecast, and warning to observation, forecast, expected impacts, and risk-based warning. So while doing so, actually, there are challenges, but there are methodologies, there are solutions, and there are also certain practice being carried forward by certain countries. And India also has done something. I will give some examples in my presentation so that other countries can also move in that particular directions. I am aware that certain countries like Nepal, Sri Lanka, and Bangladesh, they have gone for some kind of impact-based forecasting in short to medium range. And especially with respect to cyclones, they have also the impact forecasting. But in other cases also, they have gone for impact forecasting utilizing the GIS platforms. So what we want to actually do, that it should be user-specific design concept. When you go for impact forecast, you should not think from the NMHS field of point of view. You should discuss about the user point of view. And that means you should keep your mind about the state, city, district, state, house in your objective. You should keep the various exposure conditions in your objective, and you should consider the vulnerability of those masses. So you have to inform, and that means weather forecast to impact forecast, and from hasty decision to well-prepared plan, and from isolated data to an integrated system, we have to move. And from forecasting to interaction. The gone are those days when a meteorologist can just simply tell that weather is likely such and such. Now, in this scenario, in the scenario of impact forecasting, you have to go for interaction. Continuously, a meteorologist has to interact with the disaster managers, general public, not this is fire and forget. So that means if I just want to say that what we want to do actually, we have to merge two sets of data. One is the weather data that is generated by the NMHS. Other one is the impact information, vulnerability, exposure associated with the socioeconomic conditions. Hello? Hello? Dr. Raju, are you telling something?
No, sir, no, sir. It is somebody is speaking.
Fine. Can I continue? Okay.
Yes, sir. Yes, sir.
Yes. So what we do actually, we translate the weather information and impact information and also create some kind of response scenarios. And if you do that, then weather analysis and forecasting data will be converted into express relevant information, placing in suitable context, and mitigation strategy will be developed. So the time will come when this this green triangle and the orange triangle will merge with each other, and then only we'll have the complete impact-based informations. So by that way, what we have to do now, first we have to understand the warning needs for early actions, then hazard forecasting, then likelihood of the impact. And it is possible only if we have the partnership and collaboration with all agencies, those who are dealing with this. Then risk assessment, that is hazard, exposure, and vulnerability, then level of impact. So once the impact forecast is generated, it has to be disseminated quickly in a standard manner. Then we can have the prepare and early actions. So that means this slide explains the early warning and early actions. And of course, this impact forecast needs to be reviewed, to be verified, and hence to improve from the time to time. So in India, what we have done actually, we have gone impact forecast in 4 stages. The first stage is the threshold method. That means you define a forecast threshold at which people or infrastructure in a specific location are expected to be negatively impacted based on the vulnerability of that location or infrastructure. The second step, that means, for example, I may say that if there is heavy rainfall exceeding 10 centimeter, it will cause floods or it will cause damage to the transport, it will cause damage to the slums. So that is my threshold. If I am expecting 10 centimeter rainfall, I will issue the impact forecast. I will issue the red color warning or orange color warning. Next step is the qualitative combination methods. That means I will create a composite index that combines relative vulnerability with forecast hazard magnitude. So what we do in this stage actually, based on the historical data, whatever we have got some kind of historical knowledge about the impact of the rainfall, impact of temperature, or impact of any other parameter, that you combine subjectively. So this is a qualitative assessment, and this is decided through a video conferencing system among the forecasters. Third part is important, that is the impact modeling. So what we do actually, we define a geographical area. Over that geographical area, we consider the past historical damages because of a particular severe weather. Then we develop an impact matrix, and that impact matrix is utilized for providing the forecast of the impact for a given city or for a given district or a given meteorological subdivision. And fourth stage, that is climate sensitive method, that is the ultimate and that is the final step. What we do at that time, that we collect all socioeconomic database, digital database, climate hazard database, also exposure database, and all the database are put up in a geospatial platform, and hence the risk is evaluated. So that is the ultimate goal. We have done something to certain hazards, and that I will demonstrate here with some examples. So those countries who have not started, they can start with threshold method first. They can go to qualitative combination thereafter. And third step can be impact modeling. And fourth step will be the final step, that is climate sensitive modeling. So this is the first step what we started. After Kedarnath episode, if you remember, 4,000 people died in Uttarakhand. And we started this color-coded warning based on the WMO criteria, green, yellow, orange, red, based on the likelihood of occurrence and based on the expected impact. This is just subjective, and this is just based on threshold. This red color means there is warning, orange color means there is alert, yellow color means be watchful, be updated. So this was started. And then thereafter, what we did actually, we went for second stage. The second stage, we went for a video conferencing based on whatever data we have. And accordingly, we decided that we'll go for that combination, qualitative combination of the impact and the hazard. And accordingly, risk was provided. This is just an example of heavy rainfall warning. When we expect over a particular subdivision, based on this method, we started doing this. And this method was adopted in 2018 and 19. When I went to 2020, what we did further, that we went for the third stage, that is the impact model methods. So we defined the impact matrix based on the historical data available, the expected impact with respect to different sectors. Accordingly, we introduced the 4-stage heavy rainfall warning. You can just see an example of the 4-stage heavy rainfall warning for the districts of Gujarat. And by that time, what we did actually, we collected the climatological data and past impact for different types of events, developed a generalized impact model. It is not digital model, it is a generalized impact model, that's the impact matrix for different events. To commence with, we went 25 capital cities in 2020, and now we have got for all the capital cities. So then came the stage 4, the climate sensitive method. Here we combined the socioeconomic baseline data and climate data with the hazard data from various numerical models. So 2021, which was partially dynamic impact-based forecasts with a decision support system. Here all districts or cluster of districts throughout India are covered, and continued improved ongoing of real-time IVF. There is modification of bulletin formats and SOP. Data collection drive we took. We collected all types of data from the state government and remote sensing agencies, the central governments. We tried to do maximization of the exposure data. Then during 2022, we developed the GIS website. In the GIS website, now you can find out all types of severe weather informations. The GIS website is now being superimposed to the socioeconomic data and secondary hazards and the meteorological hazards. So layering and merging of information started in 2022. And accordingly, decision support system for each and every severe event is being developed. So this is just an example of heavy rainfall. You can see you have got a lot of information with you which can be utilized for impact-based forecasting. For example, you have got the past data of rainfall, you have got the future data of rainfall. I will tell you, IMD is ready to provide all types of support with respect to the forecast data and development of the IVF in the South Asia. And the digital data, whatever required from modeling support from IMD, we will provide for that purpose. So we can help in development of standardized SOP, we can help in developing the customized bulletins. One more thing, what we did actually in this exercise, that we went for automation of processes, because it becomes very difficult to go for each district and each station forecast impact method. So automation we have ventured into, and it is in process. We are sure the entire process will be completed within 1 or 2 years. So this is just an example of what are the model support available for South Asia and what are the methodology we have adopted. So you can do for similar situations, and you can help to develop the impact-based forecast. So this is an example of how we utilize the open source data set. That is pan-India, we collected the OpenStreetMap data sets. Of course, government data set we collected. Left-hand side is the open source data and right-hand side is the government data. We are utilizing both at present. Gradually, the exposure quality will improve, data quality will improve as and when we go for entire data. You can just imagine what type of data we have collected. Railway network, road network, major points of interest like hospitals, schools, colleges, administrative buildings, shelters, industries, railway stations, bus stop, airport, hotels, tourist spots, water bodies, communication towers, power plants, power stations, oil refinery, fire stations, zoo. You may say that yes, whether the location is quite accurate. Location may not be quite accurate. There is little difference because it's open state data, but it is being augmented with the government data. Certainly, it will improve further, but it will provide the first-hand impact forecast, utilize the impact models. So just an example of what impact model we are doing with respect to floods. At the city level, we have the urban flooding system, which is providing flood warning. It has also socioeconomic data. For South Asia flood guidance system, we are providing all the countries with resolution of 4 by 4 kilometer. There you can find out flood depth, flood risk, and flood threat, etc. in different color codes. And also, we have got river and flooding system, Central Water Commission. Similar with respect to cyclones, which is very old case, and we have been providing all types of forecast, starting with 15 days ahead external forecast. We also provide impact-based forecast for different sectors, be it ports, be it fishermen, or be it aviation, or be it maritime activities. So just an example of how we are issuing the impact-based forecast with tropical cyclones. The forecast of tropical cyclones starts with track intensity forecast, and with this correct intensity forecast, we go for giving the different types of impact forecast for floods, for heavy rainfall and floods, then winds and storm surge. This is just an example of how do you go for flood mapping with respect to tropical cyclones. We have the flood modeling, and we have got the flood as a hazard because it probably makes some precipitation in the past. And right-hand side, you can see the flood mapping on real time with a dynamical decision support system. Here also we find out what are the exposures due to the floods when it is moving towards this cyclone Amphan, we're moving towards West Bengal. So 24 program districts were exposed, and the exposure conditions are calculated and given to the government. Now, similarly, with respect to winds also, we have gone for development of the climatological hazard of the winds in the cyclones and its impact with respect to mariners and with respect to other insurance agencies, disaster authorities, etc. So this is an example of how the wind zoning was done during tropical cyclone Amphan, and it is an example. And it's you can see different types of color codes and different types of exposures are calculated, and it helping the disaster management authorities. This system, which has been developed by National Disaster Management Authority and India Meteorological Department, it is located in India Meteorological Department, and real-time products are being generated. And it is a very good example of the public-private partnership between state and central agencies and other agencies. And it is available to the block development officers and tahsildars so that they can take actions at the grassroots level. Now, this is just an example of the storm surge. You can find out there has been various methods for developing storm surge and coastal inundations. With all these inputs, we go for storm surge mapping and risk assessment. This is just an example of the cyclone Amphan again, how we are providing the storm surge mapping for different coastal belts. And also we here indicate what are the exposures which are to be affected by the storm surges. Now coming to the mesoscale events, thunderstorms, hazards, for example, there are also the vulnerability assessment. We have prepared some kind of matrix with respect to vulnerability to lightning, vulnerability to wind, vulnerability to dust storm, vulnerability to hailstorms. And these are being used to provide the risk-based warning. This is just an example of lightning and thunderstorm-based warning. You can find out this is just based on the expected historical damages with the strong winds. This is another work what we have done with respect to the mesoscale events. We have gone for some kind of hazard mapping. Again, strong winds, tornadoes, dust storms, thunderstorms, etc. And based on these hazard mappings, we are providing the forecast. This is just an example again, the hazard mapping with the model products. So it helps to have the conversion from hazard to impact and hence to risk assessment. This is just an example. You can find out the hailstorm, for example, dust storms, for example, the middle figures. So what we do actually, we utilize vulnerability atlas of India, we utilize the BMTPC atlas, we utilize the climate hazard vulnerability atlas of IMD. Recently, we have come up with the atlas where you can find out hazards which has caused at least one death per district. So that type of hazard zoning help to have a fast-end information to provide the impact forecast. Last but not the least, I just want to say that heat wave in this region also, heat and cold wave in this region also are hazardous. We have also done some studies for preparing the models, preparing the impact models for the hazards. This is an example of the climatology here. At first, you have to prepare the climatology if you want to go for impact-based forecasting. The second step, what we did actually, we went for some kind of forecast based on the color coding.
Excuse me, Dr. Mahapatra. We are running out of time.
I'm closing.
Okay, thank you.
Okay. So what we did actually, to have the impact, we consider the wind, relative humidity, and hence develop the vulnerability index. And based on that, now we are preparing the various combination of the impacts of the heat wave, say impact due to relative humidity, impact due to number of days of higher temperature, impact due to number of days of lower, that is minimum temperature. And we are giving different kinds of weights to different types of information. And sum of weights or index is being developed. Based on that, you can find out the hazard proneness and vulnerability proneness. Last but not the least, this is the urban heat island effect. You have to give special attention to the urban areas, as we know that urban areas in South Asia are becoming more prone for the hazards. And here also we are putting up the various types of stress attributes. For example, here national highways and railways. So I conclude here that impact-based forecast is an essential science. It is picking up in South Asia. IMD can provide support for development of IVF in the region through regional mechanism like RSMC tropical cyclones, RSMC severe weather forecast demonstration project, and RSMC South Asia phosphor guidance systems. We have introduced some kind of crowdsourcing, and that in Nepal also there is some crowdsourcing that will help to have the feedback from the citizen or the citizen science. Artificial intelligence and machine learning we are venturing into. Already we are practicing in certain fields. And the future is the digital forecasting. We will be going with a dual engine approach with both entropy and dynamical statistical modeling and data science. Digitalization of socioeconomic data is the key to the success of impact-based forecasting that we have to take off for the South Asia. Then geospatial applications will help for impact-based forecasting. And finally, the last mile connectivity, because South Asia is very remote place. There are many hills and many deserts, etc., and also sea areas. So that is taken into considerations. So thank you very much.
Thank you very much for pointing out the importance of the impact-based forecast. Now let's move to the next talk. Our next talk is about reducing disaster risk through early warning system in the Hindu Kush Himalayas. I invite Dr. Prema Gaskar Esko, the DG of International Center for Integrated Mountain Development, and Dr. Mandira Chestra, the Program Coordinator of Climate Services in the Integrated Mountain Development of Integrated Mountain Development in Nepal. The floor is yours.
Hey, thank you very much, Dr. Prem Chandra. First of all, let me also thank all the previous speakers, including the Honorable Chief Guest, Dr. Ravi Chandra, for the very interesting talk. I think we are in the middle of very prominent scientists and luminaries, and I claim no expertise in this field, so I would be inviting my colleague, Dr. Mandira Shasta, who is looking after our climate and meteorological services at ISIMO, to speak after me. I'll just give a short introduction. So I think the importance of meteorology in dealing with the challenges that we are facing from climate change is being highlighted, and it's very important for us to have a strong network of organization. And I'm glad that SAMA is doing a fine job in bringing all of us together. As already also highlighted by the Honorable Secretary, Ministry of Earth Services, the Hindu Kush Himalayan mountains are facing enormous challenges as far as climate change impacts are concerned. But the important thing for us to recognize is what happens here in the mountains matter elsewhere. It's not just the people in the mountains that would face the consequences, but also millions of people living in downstream areas. There is now unmistakable trend that every successive year it is turning out to be warmer than the preceding year. A warmer month, season, or year translates to higher moisture content in the atmosphere, extreme temperature differences, and consequently leading to heat waves, intense cyclogenesis, extreme precipitation, and destructive windstorms. In the Hindu Kush Himalayan region, the hydromet and climate-induced disasters are occurring with greater magnitude and frequency. We are witnessing natural hazards being unleashed with more intensity and higher frequency, and when least expected. Among several catastrophic events of last year, the Chamoli flash flood in Uttaranchal, India, the Melamji river flood in Nepal, the Laya permafrost collapse in Bhutan, and the drought and wildfires in other parts, to cite just few examples, are reminders that disasters will continue to escalate under changing hydromet and climate conditions. This region, through the active involvement of ISIMO, has co-developed and operationalized several variations of weather and climate forecasts to support the installation and establishment of end-to-end early warning systems against floods and other climate-induced disasters like drought and windstorms to prevent loss of lives and properties. Over the years, this system may have contributed to saving lives, securing livelihoods, and protecting economic assets, but rarely achieved the full potential benefits from early warning systems due to several challenges in the service chain. These are largely institutional. I think we have heard. I think we have problems within the member countries, within the national organization, but also across the region between countries. So there's need for us to do more networking and more cooperation. I would like to say that the weather and climate predictions are still, I think, work in progress. The science is still not perfect, and the forecast-based early warnings often result in unexpected response that erodes the trust and credibility for the people for whom they are designed to take appropriate action. Such trust deficiency can only be addressed through building dialogue on strengthening the capacity of understanding and interpreting in the proper context. Early warning is only as useful as the response taken when it is received. The capability of stakeholders to respond to a warning must be strengthened and place resources at their disposal to take actions in a cost-effective manner, even under critical resource constraint. I hope that in the coming months and years, we will be able to work closely together and further strengthen our capacity to meet the needs of our people and protect them and their assets from climate-induced disasters. I look forward to working closely with SAMA, the WMO, the UNESCAPE, and of course, our regional member countries towards building a safer, and more prosperous Hindu Kush Himalayan region. Thank you, and over to you, Mandira.
Very much, Dr. Pema, for that excellent speech. What I will do is now provide a short presentation, and I'm just getting ready to share my screen here. Please let me know if it has been shared in full screen mode. Okay, has it been shared in full screen mode now?
Yes, go ahead.
Okay, great, thank you very much. Again, a very good afternoon, and I'm delighted to be part of this program celebrating the World Meteorological Day and sharing with you some of our experiences in terms of reducing risks through early warning systems in the Hindu Kush Himalayan region. I'd like to thank Sama for the opportunity, and of course, my Director General as well. So I'd just like to introduce to you the HKH region. I know all of you, in fact, most of you present here probably know this, but it's important to just reflect on it as well. So this region, the Hindu Kush Himalayan region, we extend about 3,500 kilometers from west to east and covers 8 countries. And then it houses about 240 million people. And the resources from this region basically meets the needs of more than 1.6 billion people living in the downstream. We also know that we are the youngest geological formation, so thus we are very dynamic as well as a fragile mountain ecosystem. In terms of the high spatial variation, both topography as well as climatic conditions pose us immense challenge. And given the fact that we are the largest reserve of snow and ice outside the polar region, we are also known as the third pole. And the 3 major river basins, the Indus, the Ganges, and the Brahmaputra, emerge from the HKH. Now, looking at the climate context, I think in a 1.5 degree world, like has been said already, there's temperature dependent warming in our region. That means that our region is warming much faster. It's like 0.3 degrees higher in the Hindu Kush Himalayan region. And if you look at it in the Western region, as has already been said by the Honorable Secretary also, it's even more, 0.7 degrees in the Karakoram areas. Now, this was an outcome of a study that ICIMOD issued way back in 2019 regarding the HIMAP assessment, the Hindu Kush Himalayan Assessment Report. And in this report also, what has been reported is that the precipitation extremes are increasing. That means we're going to have more extreme events as well as erratic rainfall. And this is something that has already been highlighted also in the IPCC 6 report that was launched recently. Now, what does it mean when we say 1.5 degree world for us? Well, our glaciers in the HKH region will lose more than 1/3 of its volume by 2100. What does it mean by business as usual? 2/3 of the volume on the current emission trends will, of the mass will be lost. So that means there's going to be increased snow melt in the region. The peaks are going to rise. And therefore, there's a need really to look into this for better preparedness. There's likelihood of glacial lake outburst floods from the upstream, as well as other impacts that you will see in the downstream. Now, as has been highlighted already, the Hindu Kush Himalayan region, when you're looking at the statistics, 21% of all the global disasters is from the Hindu Kush Himalayan region. That's quite a lot. This is from the EMDAT database. And if you're looking at it for Asia alone, it's 36% of all the major events. And then the report that I just mentioned, HIMAP, also mentions that 1 billion people are at risk of increasing exposure to these disasters, both in terms of frequency as well as intensity. And out of all the different typologies of disasters that we've heard today, 1/3 of these disasters are just accounted by floods alone. And these are crossing borders, these are transboundary in nature. And we also must keep in mind that these disasters have differential impacts. That is, it affects women and men differently. Now, the cascading natures of disasters in our region, this is very prominent. The cascading disasters, the hazards has already been highlighted in the presentation earlier that we've heard from UNSCAP, and that the multi-hazard environment that we live in. You just heard again about the 2 disasters, the recent disasters that we had in 2021, the Chamoli disaster, for instance, the Melamchi floods in Nepal in June of 2021, all highlighting the need to really concentrate and focus on cascading hazards and cascading disasters and revisit early warning systems. And really, it really is important that we look into what kind of early warning systems we put in place, impact-based early warning systems. So this needs to be looked into. Now, in terms of reducing the risks, we have this framework that was provided by IPCC earlier, where risk is a function of 3 elements: hazard, vulnerability, and exposure. So in order to reduce risks, you're looking at various factors, various parameters, and that includes, looking at the knowledge base, for instance, increasing the knowledge base, like you heard today, the research that goes into developing early warning systems, or partnerships. That is essential. Then gender mainstreaming, I think this has not been sounded yet, but it's very important that we look into these issues also. And governance and institutions are crucial in early warning systems. Finance, I haven't heard anything about finance. I think finance is very much important. Investments in early warning systems and nature-based solutions. So we need to also look at how we best use the science and technology that we are presently available, and have the cutting edge technology for risk reduction. And I think some of the examples that we heard from the DG of IMD were some of those that reflect the need to really look into harnessing the science and technology for early warning systems and put in place a people-centric early warning system. So there are many innovations in terms of technologies in end-to-end flood early warning system. Here I give you an example where we start with definitely the data collection and monitoring, the transmission of these data, the modeling of the data that you heard, the assimilation, the communication of that data, and then timely action. Now, in addition to this, of course, what you have heard today is essential in terms of more looking at risk-informed decision-making. So really linking it to risks and impacts is essential. So I'll give you some examples that we have been engaged over the last few years with our partners in the region, with the hydromet agencies. One is the HKH HYCOS, the hydrological cycle observing system that we work together with. And this as a part of the World Meteorological Organization project, where we looked at modernization of hydromet networks, putting in systems, real-time data exchange, and with the motto of making information travel faster than floodwaters. And an important achievement of this particular initiative was that the technology transfer. I think we also heard about technology transfer this today. So training and capacity building, which enabled the countries in the Hinduksh-Himalayan region to really attract larger funding for modernization of their hydromet networks. Now, the example of that is the big funding that we had in the project that we had, the PPCR funding in Nepal, the funding from the World Bank in Bangladesh, in Bhutan, in Pakistan. So this is something that we are happy to see. And the other example that is also very important is the community-based flood early warning systems that we have been working again with the region. And we've currently have these in place in Afghanistan, India, Nepal, and Pakistan. And the whole crux of this is that the communities are the first responders, and they are central to this whole work that we are doing. And this community-based flood early warning system has been, again, like I said, been used and is being quite common, or not common, but I would say that it is more and more being used by our partner countries in terms of reaching out to the last mile. Now, in addition to that, we have the mapping and modeling of these techniques, the flood monitoring and modeling. So example of this is the flood outlook that we've worked with our partners, the HIWAT modeling that we've been working with various countries, with Nepal, with Pakistan, with Bangladesh, as well as in Bhutan, looking at high weather impact assessment tools. And then we're looking at also how we translate that into flood inundation mapping, looking at hydrodynamic modeling, and using SAR images, Sentinel images for flood inundation mapping, as well as ICIMOD has the regional database system, RDS, where the repository of data and information is there. So I think this is equally important to look at. I'll give you an example of the regional flood outlook. So this is just an example where we're using both the data, that is the observed data sets, as well as the Earth observation data sets, looking at hindcast, looking at then a 3-day forecast, and using the quantitative precipitation from the GFS, but also other inputs we are using from NOAA, and coming up with this 3-day forecast for flood outlooks for the Hindu Kush Himalayan region. And this is in operation for now quite some time, since 2014. 2014, and the countries are using this to prepare flood advisories. So we continue to engage with the countries on this. And then now the question remains as to what makes a good flood early warning system. And that is primarily, it's not only about advanced forecasting and warning technology. Of course, definitely there needs to be a lot of emphasis for improving the advanced forecasting and warning technology. But again, equally important is the functional institutions, the governance that needs to be looked into, because you need to have these institutions where the mechanisms are there for the information to be conveyed down to the users. So the last link to the communities and people at risk is important. Multi-stakeholder partnerships at all different levels, the communities, the civil society, private sector, academia, media plays a very key role in terms of getting that information down. So the whole chain is very important. And therefore, we need to really focus also on the communication continuum. So it's not only about being aware of the information or understanding of this information, or whether the communities accept it. I mean, you need all of that. They need to be aware, they need to understand, they need to accept. So the information that is generated needs to be brought down to the community in such a way that all these are achieved, so that it is actionable, so that there is a behavior change. So this communication continuum is an integral part of early warning systems, of impact-based forecasts, you may call it, and needs to be strengthened, because this is one of the weakest links when it comes to early warning systems. So finally, what I would like to here now again emphasize is about the multi-hazard early warning systems. Just because we're looking at cascading hazards, it's not only one hazard that you're looking at. Definitely, I talked quite a bit about floods, but again, different hazards are there. So this needs a bit emphasis in terms of it, and that's also very much sounded in the Sendai framework for disaster risk reduction. And integrating risk information into early warning systems is important, and that's where impact-based forecasting is critical, particularly for anticipatory action that we've talked about. It's not only about what the weather will be, but what the weather will do, what are the impacts, so better preparedness will be achieved. Then data and information are crucial, and so for which you need a proper data infrastructure, and then co-designing and co-developing tailored climate services is essential. So it's not only about us, it's not only about push, but you have to also be very much demand driven and designing it with the people, the users. And sharing of information is also critical, because often the data is not adequately shared, or it's in different places and needs to be put together. So that needs attention too. Technology and innovation, yes, for data assimilation, for validation, for instance, this becomes very critical. And not only that, for processing of the data information, using the latest technologies such as GIS, remote sensing, or various networks is crucial for an effective early warning system, like we have been doing through several of our programs, like the Survey program, which utilizes space-based applications, and as well as the climate services, where we are working with various organizations like the Met Office, as well as our partner organizations, the hydromet agencies in all our member countries, Nepal, India, Bangladesh, Bhutan, Afghanistan, Pakistan, and to put such a kind of a mechanism in place. And central to all these activities is capacity building. So I think this is important at all different levels. So building the technical capacity, understanding capabilities, and improving the coordination as well as the communication. And finally, what I would like to stress here is the fact that multi-stakeholder partnerships is very essential. And since most of these disasters are transboundary, needs a lot of transboundary cooperation as well as regional cooperation to address these risks. And climate investments is essential. Particularly, having one type of early warning system or a multi-hazard is not adequate. This Hindu Kush Himalayan region is a large region, so we need to scale up actions. So scaling of actions is essential and needs attention. So particularly for risk reduction and building a more climate resilient HKH for a safer Hindu Kush Himalayan region. Yeah, so thank you. I will end at that and will hand it over to our moderator, please.
Lydia.
Thank you, Dr. Gamis Gasco, for your valuable contribution. Sama highly appreciate your dedication defies the busy schedule. Also, thank you very much, Dr. Mandira, for your interesting and informative presentation. Now, let's move to our second question answer session. Dr. Mohandas and Dr. Sagata, the floor is yours.
Thank you, Tadushka. Both the presentations are very much effective for the community, and I have seen many questions, but due to time shortage, I would like to pick up one or two. One question goes to our Mandira ma'am. How is climate change affecting our farm and food and relevant issues?
Well, definitely climate change is affecting many different sectors, right? The water sector, the tourism sector, the hydropower sector, and integral to all this is agriculture. Yeah, so that is definitely the food security that we have in the region. When you're looking at the indicators of climate change, whether temperature rise or whether you're looking at the precipitation in terms of its variability, it has direct impacts on our food production. Yeah, so I could go on for quite a lot, but I will end just at that point. Thank you.
Okay. Another question, it's just asking, maybe anyone can answer. What is the most appropriate method to reduce the impact of disaster? Any specific country or South Asian region? What is the most appropriate method to reduce the impact of disaster?
Well, I will come in here real quickly because there is no one appropriate method of reducing the impact of disaster. It's a collaborative effort. Many different stakeholders, like I was mentioning in my presentation, are involved in addressing the disaster risk reduction. One of the emerging approaches that we are now talking about that has been presented is the impact-based forecasting. That is more linking it to risk-informed warning, right? So this is one of the methods. But again, I would not say that this is the most appropriate because as the technology changes, as we are moving forward, there are many things that will improve and move forward. But definitely, that's one of the ways. Thank you.
I think there is no more questions. That's not
right.
Time is not that much, so we can proceed for the next part.
Okay. So I hand it over to the moderator. Thank you, Mandira ma'am, and thank you, our distinguished presenters.
Thank you, Dr. Mohandas and Dr. Sagata. Please allow me to invite Sama convener, Professor Somavas Das, to announce the result of the quiz question.
Thank you very much, Chatuska Premchandra. Just let me share the screen. Just a minute. Is my screen visible?
Yes, sir. The last slide.
Yeah, is that okay?
Yes.
Well, one of the objectives of SAMA is to encourage young students to create awareness and interest among them about weather and climate sciences and academia partnership for the promotion of the meteorology and its societal applications. So SAMA has formed a special committee on education and outreach. In this regard, SAMA has been conducting workshops and quiz contests for the school children. We had conducted earlier Ozone Day quiz in September 2020, and recently we have conducted the climate science quiz contest for the students of class 9, 10, 11, and 12 during 22nd February to 25th of March this year. This is for the students of all the member countries of SAMA. Well, this is just a quick summary of the registered students. We had total about 959 students registered for the quiz competition from all the countries, including India, Afghanistan, and so on. Of course, maximum was 524, followed by Sri Lanka 155, and then Bhutan 55 students, Afghanistan 20, etc. Well, these are the results. We have decided to reward the top 3 students from each country which participated. And there were 25 questions asked in about 15-20 minutes time. The page was open round the clock from 22nd of February to 25th of March, so that students could participate in the quiz contest as per their convenient time. And these are the results for India. Of course, the multiple students who have scored the top scores, highest score is 25. So about 6 students scored 24 out of 25. 13 students scored 23 out of 25, and 11 students scored 22 out of 25. That's the result for India. So of course, we will reward all these winners from India. Then from Afghanistan, about 2 students scored 13 out of 25. 1 student scored 12 out of 25, and 2 students scored 7 out of 25. So they are the first, second, and third top winners from Afghanistan. From Bangladesh, the top winners are 3 students scored 25. 1 student scored 15 out of 25, and 2 students scored 12 out of 25. So they are the top 3 winners from Bangladesh. From Bhutan, 3 students scored 20 out of 25. 2 students scored 18 out of 25, and 3 students scored 16 out of 25. So they are the top 3 winners from Bangladesh. From Myanmar, of course, only 1 participation was there. So obviously, he is declared as the winner. Then from Nepal also, although many students registered for the quiz, but only 1 finally completed successfully. And so we have only 1 winner from Nepal. From Sri Lanka, the top student scored 20 out of 25. Then the second winner scored 19 out of 25. And 3 students scored 18 out of 25. So they are the top 3 winners from Sri Lanka. We had also a good male versus female ratio in the participation in the quiz competition. So Sama has decided to reward all the winners, top 3 winners from each country who participated. Of course, unfortunately, 2 countries could not participate. One is the Maldives, and another is Pakistan. But all other 7 countries participated in the quiz. And Sama has decided that it will reward all the top winners. The first reward will be given as a merit certificate to the top 3 students from each country. The second reward will be an e-book related to weather and climate science for their standards, because they are just 9, 10, 11, and 12 standard students. And the third reward will be an opportunity to interact with some of the renowned scientists online. So these are the 3 rewards which will be given to the top winners from each country. And of course, all the participant students were given the participating certificates for this quiz contest. So with this, thank you so much, Chatuska, and now up to you.
Thank you, sir. Now I invite Dr. Qamar Saman Chowdhury, the former DG of the Pakistan Meteorology Department, to conclude the remarks.
So your mic is mute.
So your mic is mute. Right.
Thank you. Good afternoon to all my colleagues. And I am grateful to my colleagues in Sama, who have invited me and gave me this opportunity to talk to and meet my old friends. As we know that the theme of this year WMO Day is early warning and early action. And in fact, I will be very brief because my earlier colleagues, they have already taken up in detail all the aspects. So I will just wanted to highlight one aspect. As we know that the most important this area of meteorological services is to provide the early warnings so that the appropriate actions can be taken. But I think to achieve this goal by the meteorological services, one aspect, I think, the most important aspect, I think, without which the meteorological services cannot deliver is the regional cooperation. Meteorological services are providing, I think, this opportunity for an international exchange of data and all that. But I think our SAMA can, I think, provide this opportunity for the regional cooperation, irrespective of the political affiliations, political circumstances, I think. And luckily, in our region, we are, I think, having a good cooperation among the meteorological services. They are exchanging the climate data and hydrological data. And I think this is the most important part and the responsibility, or I think facilitation, which SAMA can continue to provide. And in fact, they can increase this cooperation further. So I just wanted to highlight this aspect of the regional cooperation, because in the absence of regional data, I think no meteorological service can, I think, provide the better early warning or forecasting systems. So I will just keep myself limited to this suggestion and this, I think, input. And I think I will just stop here, and please, Prema Chandra, over to you.
Thank you very much, sir, for your valuable contribution. Finally, I invite Mr. Hassan Wahid of Maldives Met Service to deliver the vote of thanks.
Thank you. Thank you very much. Yeah. Honorable Chief Guest, Dr. Ravi Chandran, Secretary, Ministry of Earth Science of India, and Professor Ajit Tyagi, Chairman of SAMA, and all distinguished speakers and participants. Good morning, all. I'm Hussein Wahid, meteorologist working at Maldives Met Service. It's my pleasure and privilege to present a word of thanks for this special occasion. I extend my gratitude to Honorable Chief Guest, Dr. Ravi Chandran, to take out time from his busy schedule to grace the event. Thank you for inspiring and encouraging us with your words on this special day. I would like to express my gratitude to all esteemed 6 experts for their presence and contribution to make this meeting a great success. It is such an honor for me to get the opportunity to thank you all participants. On behalf of SAMA, I extend a warm welcome to all the participants in this meeting. A special thanks to Professor Ajit Tyagi and our chairman, and Professor Someshwar Das of SAMA for providing immense support to make this occasion successful. I also extend my gratitude to Executive Committee of members of SAMA and India Meteorological Society for organizing this event. I congratulate all the winners of quiz competition, as well as all the participants for their active participation. Thank you everyone for taking time to be here for today's event. Have a great day. Thank you very much all. Thank you.
Thank you very much.
Before leaving, shall we have the group photo? Can
Yes.
you switch on all the participants, open the video?
Already taken, but still some Indira Kadal ma'am, Dr. Wahi.
Still we're waiting for some people,
Yeah.
some participants open their video.
Nice to see you, Dr. Ashit ji. Saidul Sarkar Bhai, could you please open your video? Dr. Abdul Momin, Colin Wu, Tinmar Este, MDPC1. Any other? Okay, I'm taking one more again. Yes, great. Just 1 minute. Wahid bhai, you wish to say something?
Hello. Can
Yeah.
can I ask any questions? Actually, my question is, do the policy can make any solution to reduce the climate change impacts? Because you know that UNFCCC working for some every country, but actually we cannot yet see the exact result from the law or policy, etc. Can policy make any solution to reduce our climate change impacts?
Yeah, I request Dr. Ajit Tyagi and Dr. Chaudhary sir can comment on this.
Right. Ajit Tyagi sir, unmute please.
Well, I know the high-level interventions through COP mechanism is done by the head of the states, and various initiatives taken by these are long-term and short, medium-term mitigation measures which can reduce the global warming. Apart from this, each country has to work out its own priority areas and policies accordingly. No uniform. So each country has been given national determined targets to reduce the greenhouse emissions. And based on that, I think each country is working out their policy mechanism and programs to reduce the carbon emissions, and also develop capacities to reduce the disasters. And early warning system is one of very important aspect of it. So early warning to early action also is an initiative towards that direction. But essentially, yes, the policy decisions are taken at the apex level, and they are discussed in the COP meetings, and hopefully each government accordingly takes action. Thank you.
I would like to add something if I'm allowed.
Thank you, sir.
Now we are going to end the meeting, and thank you very much for your active participations. Looking forward to see you in more in the summer activities. Sir, any comments, Dr. Das?
Yeah, next Sunday, actually, we are having this marathon activities of summer. And next Sunday, we are planning to have the 4th meeting of the advisory committee of summer. I have already circulated the post mail regarding this, and more mails will come. And of course, the most importantly, on 10th of April, we will have a general body meeting of all the members of summer. So please do attend the GBM on 10th of April. So that's all from my side. Tyagi sir, any closing words from your side? Of course, we thank the thanker, Mr. Hussain Wahid, who thanked all of us. So let us thank Mr. Hussain Wahid also from Maldives Meteorological Service. Yeah. So Tyagi sir, service stop now?
Yes, sir. Thank you, sir. Thank you very much, and see you soon.
Thank you, everyone.
Thank you.
Thank you.
Now the host can close the meeting.
I think Shagataji may be not there. So it may be difficult to
close. I see.
Yeah. There is a very good comments from Gitesh Vasan. Very good.
Yeah, I think he raised some question also.
Yeah.
Yes,
Actually, I tried to speak. Hello, am I audible?
Yes.
Actually, I tried to speak at that time also. I think there was an internet problem. So I typed everything, which I wanted to convey.
Thanks for your effort.
So you can switch on video, Gitesh, if you want. Well, the experts have now left.
Hi, sir. How are you, sir?
Fine, Gitesh. How are you?
I'm good, sir. Actually, one of the participant asked a question related to the policy making. So I was working with on this particular project related to policies. So that's why I thought I can just give my inputs in this.
Sure, yeah. Yeah. You would like to say something on that?
No, I just typed everything which I just wanted to say that related to this.
Yeah. Anyway, so good that you attended. By the way, Gitesh is our student, alumni from Central University of Rajasthan Department of Atmospheric Sciences.
Oh, great.
So where are you working nowadays, Gitesh?
Sir, at CEW, Council on Energy, Environment and Water.
Okay. Yeah. In Gurgaon, right?
No, sir. It's in Sanskrit Bhavan, RK Puram.
Oh, RK Puram. Okay.
Yeah.
Good.
Probably they might be shifting to Gurgaon or Noida within few months.
I see. Okay.
It's so good to see you again, sir.
Yeah, sure. I mean, you should attend all our programs and also become a member. You tell your other classmates also.
Actually, I am a member of SAMA.
You already a member. Okay, great.
Yeah, I'm already. That's why I do attend the meetings. Today.
Very good. What about your other friends? I circulated a message to all of them, but only I can see you.
I convey those messages as well. Like whenever I receive the email from SAMA, I forward it to everyone.
Right. Good. Very good.
Okay.
So, Mohan, you're not able to close it, yeah?
Okay, sir. Thank you so much.
Thank you. Any problem in closing the session?
If the host is not there, then the co-host can also end the meeting.
I thought co-host can do that. All three of you are co-hosts, I think. Mohan, Swagata, and Professor Raju. Otherwise, shall I call the Vidyarthi Vigyan Manthan, BBM, to close it? Absolutely.
Somesh, are you waiting for some?
They're not able to close the meeting. The Zoom has to be closed.
Still, it is only leave is only allowed, but not stop the meeting.
Shall I call the BBM people or Dr. Ramade, Vigyan Prasad people?
Yeah, I think they can do it, or Dr. Shagata can do it.
But Swagata has left, right?
Yeah, he's.
Shall I call Swagata?
Yeah, I think that will be better. I also tried to communicate. Maybe some issues there. Yeah. I think you can call on mobile.
Yes. Generally, his network has a problem. So anyway, I'll try to call him.
Maybe.
I think he's not getting connected. not getting connected.
Yeah, there is some issues there.
Let me try on his.
Vidyati Vigyan can do it, I think.
Call.
Shagataji, if possible, please close the meeting and stop the live streaming of. Yes, sir. I have seen you also not in the meeting. Hello.